Hello everyone, welcome to sections 1.5 and 1.6. This lesson is going to focus on inequalities. So we have something to get you all warmed up. Let's say you have $100, but you need $500 for your bike, for the car, whatever you want. You're selling cakes at $10 a piece. How could you express all the possible numbers of cakes that could be sold to satisfy making $500? I'll give you a hint. It probably has to do with what we're learning today, inequalities. So go ahead and try to create an equation that would fulfill that. So if we have $100, let's write that down, and we need some extra money. How much extra money are we going to make? We're going to make $10 per cake. How much money do we need at the end? Well, we need at least or greater than or equal to $500 because we want at least $500 or anything more than $500 would be good. Right. From here, how would we figure out how many cakes we need to sell? Well, we'd subtract 100, so we'd be left with 10x being greater than or equal to 400, or we'd see that we need to sell 40 cakes, which in this day and age, with nobody walking around or anything, probably impossible. Not going to get you $500 that way. Have to think of something else. All right, solutions to inequalities. What are the two different ways we can represent solutions to inequalities, knowing that there's infinitely many solutions? Well, we've already discussed, or we already know, one way to represent infinitely many solutions. Think about a line. All a line is representing is infinitely many solutions. So a graph would work. We could also represent it with an equation, right? Just like x is greater than 1. Right, now we're going to get into our properties of inequalities. We're going to use the inequality 5 is greater than 1 to test these. So the addition property says that if we know one number is greater than another, a is greater than b, then when we add something to both sides, our side that was large to begin with should still be larger. So we know 5 is greater than 1, and if we added 3 to both sides, 8 would still be greater than 4. Our subtraction property is very similar. If we know that one thing is larger than another, a is bigger than b, then subtracting something from both sides shouldn't change that. Or if we had 5 and 1, subtracting 3 from both sides, 2 would still be greater than negative 2. Now our multiplication property and our division property, these are where it gets a little funky. So this one says if we know one thing's bigger than another and we're going to multiply by something greater than 0 or something positive, then we know that multiplying by that should not change the fraction. Again, if we had 5 is greater than 1, multiplying both sides by 2 will leave us with it being 10 still being greater than 2. However, if one side's bigger than the other, but we multiply by a negative number, something smaller than 0, then our inequality flips. Then our side flips, so the side that was larger now becomes smaller. Why does that make sense? Well, let's test it so we can see this. We know 5 is greater than 1, but 5 times negative 2 will be negative 10. So 5 times negative 2 will be less than 1 times negative 2. So multiplying by this negative means we have to flip the sign. And the division property is pretty much the same. If we have one number that we know is bigger than the other, but we're trying to divide by something positive, something greater than 0, then our inequality will stay the same. Then this side will still be larger. So if we divided both 5 and 1 by 2, 5 halves would still be greater than 1 half. However, if we're trying to divide by something negative, c is less than 0 meaning it's negative, then our inequality is going to flip. Again, why does this make sense? Well, if we divide this by a -5, this would give us -1, but that's going to be less than -1/5. So the negative is going to flip which side is true. This brings us to the really key rule when we're solving inequalities, which is when you multiply or divide by a negative, you gotta flip the sign. And let's underline this a couple of times, that way we remember it. Make sure you flip the sign, but only when you're multiplying or dividing. Okay, we're gonna go through some problem children, which is what I would call you all if I actually was able to see you all and see what you all were doing. For this one, we have x plus 3 over 2 is less than 20. Like we've talked about, the dividing sign acts almost like a parenthesis, meaning that we have to get rid of this 2 first. We're still going to multiply that over, so we get x plus 3 is less than 40, or we find out that x is less than 37. For this one, we got to be careful because we're subtracting n. So how do we get rid of the 6? We're going to subtract 6. And this gives us minus n is less than or equal to 6. Now how do we get rid of this negative? We're going to have to divide by -1. Uh-oh, we're dividing by a negative number. What do we have to do? We have to flip the sign. So this becomes n. We flip the sign, so now n is less than -6. All right, what about for this one? Well, we're going to subtract 5, which gets us to 2/3 x being less than -20. Now, how do we get rid of a fraction that's multiplied? Well, we have to keep change flip, or we have to multiply by the reciprocal. So we have to flip the fraction and multiply by it. This will cause our 2's and our 3's to cancel out. And what are we left with? We have x is greater than. Notice we have a negative, but we're not multiplying or dividing by it. The negative just stays where it is, so we're not going to flip the sign. So this becomes -60 over 2, or we get that x is going to be greater than 30. And then for this one, let's make sure to distribute this negative into both sides. It's really the tricky part here. So we get 3x minus 5x minus 1 is less than or equal to 10. Let's combine these like terms, so we get -2x minus 1 is less than or equal to 10. Now we have a negative on this side, but we're not multiplying or dividing. We're adding the 1, so we're not going to flip the sign. We get -2x being less than or equal to 11. But now we're dividing by a negative number to cancel these out. So now we're going to have to flip the sign. This becomes x is greater than or equal to -11 over 2. All right, now we have some problems for you to practice. What would be the solution or the inequality that would make this true? So for this one, we're going to have to add the 8. So this becomes 2x is less than or equal to -2. Then we're going to divide by 2. Notice we have a negative, but we're not dividing by the negative. So our sign's not going to flip. And our answer is going to be x is less than or equal to -1. What about for this? What inequality will make it true? All we have to do for this one is we're just going to multiply by 3 to both sides. Again, the negative is here, but we're not multiplying or dividing by it. The negative is staying where it is, meaning that we don't have to flip the sign. We get x is greater than -30. Go ahead and try this one. For this one, we have to start by subtracting the 2. So we get -3 over 2x is going to be less than -21. Now, how do we get rid of this? We're going to have to multiply by the reciprocal. So we're going to have to flip this fraction, and we want the negative to come along for the right. But wait, notice we have a negative. We're multiplying or dividing by a negative. So this sign is going to flip. This all will cancel out. So we're left with x being greater than, let's see, negative 21 and 3. We can reduce that, so that becomes 1, and that becomes 7. So this becomes negative 7 times negative 2, or positive 14. Now let's move on to graphing these inequalities. How are we going to graph an inequality? Well, first of all, we got to solve the inequality. Make sure that we have an answer for x. In this case, we're all good. Step 2, we're going to plot the point on the number line. Remember that with a less than or greater than sign, we have an open circle, but if we have a less than or equal to or greater than or equal to, we have a shadow here. So we're going to need to shade in our dot. For this one, we'd plot our number line. It goes 0, 1, 2, 3, 2, 3. And we'd go to 2. We'd put down a point that is open because we'd have less than or greater than. Step 3 is going to be check a point and shade. So now you're going to check point. I like using 0 because it makes my life simple. And if that's correct, we're going to shade to that side. So we're testing 0. Is 2 less than 0? 2 is not less than 0. So this is incorrect. We do not want to shade to this side. Instead, we're going to shade to the other side. Okay, we're going to get a little bit more practice with this. Let's just do this first one quick. We have 3 is less than or equal to x. So on our number line, we're going to go up to 3. We're going to make a dot. This dot is going to be shaded because we have our shadow underneath. Now we're going to test a point. Let's go to 0. Is 3 less than or equal to 0? It is not. So this is not the side that we're going to shade. It makes it false, meaning we're going to shade the other way. Now for this one, don't be scared. We're just going to do any algebra to all sides. For starters, we're going to add this 1 to everything. So this becomes negative 2 is less than 2x is less than or equal to 10. We're going to divide by 2 here, so this becomes negative 1 is less than x is less than or equal to 5. And now we're ready to graph this. We're going to start at 0. We're going to go down to negative 1, 2, 3, 4, 5. And we're going to put our points. For negative 1, we have an open dot because we have no shadow. For 5, we have a closed dot. And now let's test the point 0, see whether it works. Is negative 1 less than 0, but is 0 less than or equal to 5? That's true, meaning that we're going to shade inside these two dots. Now, for this last one, we have x is greater than or equal to 5, or x is less than 1. Looks like these are already solved, so let's put them onto our number line. We have 5 and 1. For 5, that's going to be filled in. For 1, that is not. Now let's test a point. Let's test 0. Is 0 greater than or equal to 5? It is not, but we need to check if it's less than 1, which it is, so we're going to shade this region. Now what about this region in here? Let's test 3. Is 3 greater than or equal to 5? It's not. Is 3 less than 1? It's not, so we're not going to shade in here. But we have to check this region. So is 6 greater than or equal to 5? It is, meaning that this is all shaded as well. Now it's your turn to go ahead and try some of these. This one, the first one, is going to come out similar to number 2, and then we have a couple where you're going to have to figure out what the actual equations are, or the inequalities are. So go ahead and graph number 1. What do we do for number 1? We're going to subtract 5, so this becomes negative 8. It's less than or equal to minus 2x. It's less than or equal to 4. That's not 4. Let's see, 11 minus 5, that'll be 6. Now what do we have to do? We're going to divide by 2x, or negative 2. Hold on, we're dividing by a negative, meaning that we're going to have to flip this. So this becomes 4. But all we're going to do is we're going to flip both signs. So 4 is going to be less than or equal to x, which is going to be less than or equal to negative 3. Now we have to graph this. So I'm going to start at 0. We're going to go down to negative 3. We're going to go all the way up to positive 4. Both of these points are filled in. And now we're going to check to see whether 0 works. Is 4 greater than or equal to 0? And is 0 greater than or equal to negative 3? This is true, meaning that this area is the correct area. I'm going to shade that in. Now we're going to try to do this one. You're going to have to come up with an inequality first and then make the graph. For this one, we get a discount if we're over 80, so our age has to be greater than or equal to 80, or our age has to be underneath 3, so it has to be less than or equal to 3. This less than or equal to, these equal to's, are debatable. If you didn't put those down, you're all good. Let's make our number line now. Starting at 0, we're going to go to 3, and all the way up here we're going to have 80. For my graph, because I said that there was those less than or equal to or greater than or equal to, we're going to shade those dots. Now, what is going to be less than 3? Is 0 less than 3? Don't forget we also need an or in here. It's important to keep that or. Is 0 less than 3? Yes, it is. So everything to this side is true because all of that's less than 3. Anything in here, is 15 greater than or equal to 80? It's not. Is it less than or equal to 3? It's not. So this area isn't shaded. But 90 is greater than 80. So we're going to shade to this side. Now for this last one. This one's a little bit harder. Now we have 120, we weigh 120 pounds, and we're carrying 10-pound chihuahuas. But we need to make sure that our total weight when we're riding a horse down into the Grand Canyon with these chihuahuas is at least 140, but at most 200 pounds. For this one, let's start with our equation. What's the total weight going to be? Well, we weigh 120 pounds, and we're bringing an unknown number of 10-pound chihuahuas. So this is going to be our equation for weight. What do we want to be true about the weight? We want it to be less than or equal to 200 because our weight has to be at most 200 pounds. But it also needs to be greater than or equal to 140 because we need this to be at least 140. Now we're going to solve by subtracting 120 from both sides. We get 20 being less than or equal to 10x, which is less than or equal to 80. And then when we divide by 10, this becomes 2. It's less than or equal to x, less than or equal to 8. So we can bring 2 chihuahuas up to 8 chihuahuas, which honestly 8 chihuahuas seems like a lot. We might want to stick to the lower end of this. Now let's graph this. So we have 8 here, we have 2 here. Let's choose a number in between to see if that works out. Is 5 going to work? So is 2 less than or equal to 5, which is less than or equal to 8? That does work out, meaning that this is our area. And I forgot to put in my dots. So that's our solution. On to our last part of this lesson, which is honestly the weirdest part of this lesson. We're dealing with absolute value equations. So we dealt with this yesterday, but how do we solve 3 absolute value of x minus 2 minus 1 is equal to 11? Well, to start, we get everything away from the absolute value, so we add 1. We get 3 absolute value of x minus 2 is equal to 12. We continue to get the absolute value by itself, so we divide by 3, get x minus 2 is equal to 4. What did we do here? Well, we split this up into 2 different equations. One where we were looking at a positive 4, and one where we were looking at a negative 4. Because remember, absolute value is distance. So this could be at positive 4. Positive 4 is 4 units away from 0. but negative 4 is also 4 units away from 0. Now we're going to be dealing with absolute values in inequalities. What are our rules for absolute values in inequalities? If your absolute value is less than something, then we have an inside inequality. If you had Gallagher or Baldwin last year, you might have seen this mentioned as and inequalities, because we need one inequality and the other to be true. However, if your absolute value is going to be greater than something, then we have an outside inequality. You might have heard of these as or inequalities, because we need one or the other to be true. Let's look at our example to see how this goes. First thing we're going to do, we're going to subtract 1. We're going to treat this just like an equality for the moment. We get absolute value of x minus 2 is going to be less than 10. We see this is less than 10, meaning that this is going to be an inside or an and inequality. That means x minus 2 is going to be sandwiched on both sides by the positive and the negative values. So we get the negative 10 will be less than this, but 10 will be greater, right? We're looking for something with a distance less than 10 away. So we want this to be close to 0. We don't want it to be outside going away from 0. From here, we're just going to continue to solve. So how would we get x by itself? We're going to add 2. Adding 2 to both sides gives us negative 8 is less than x, which is less than 12. When we put this on our number line, we're going to have open dots. And we said this is an inside inequality. This is everything inside or interior, meaning that all of our solutions are going to be everything inside of here. Now I know this is confusing, so we're going to do a couple more practice problems, and then I'm going to let you all try a couple. For this one, we have absolute value of x plus 3 is less than 8. What are we going to do? We're going to subtract 3 from both sides. We get the absolute value of x is less than 5. Now we're going to need a positive and a negative inequality, or a positive and a negative 5 here. This is less than, meaning it's going to be inside, it's going to be interior, or an and inequality, meaning that we'll have negative 5 is going to be less than x, and x is going to be less than 5. Right, so we're going to have two things sandwiching this together, which is going to look a little something like this. Open dots, and we said this is everything close to 0, meaning that it's everything inside of here. For this next one, we're going to start by solving for this absolute value. We're going to subtract 3, bringing us to 2 times the absolute value of x plus 1 is going to be greater than 6. Got to get this by itself, so we're going to divide by 2. We get absolute value of x plus 1 is greater than 3. Now we're going to need an or inequality here, right? This is something that's greater than. So we're going to need something that is or, meaning that we want two things that are not going to overlap. What does that mean? We're going to have x plus 1 being greater than 3, or x plus 1 being less than minus 3. So the trick for ors, remember that you want it to be on the outside, meaning that for your negative, you're going to have a less than. For your positive, it's going to be greater, right? We want it on the positive side of the positive. We want it greater than the positive and smaller than the negative. Now we're going to finish solving for this. Subtract 1, we get x is less than minus 4. Subtract 1, we're going to get x is greater than 2. Now we're going to put this on our number line. and both of these dots are open. Now we said this is everything outside or exterior, meaning that everything away from 0 is going to be our solution. Finally, for this one, let's take a look. We're going to start by subtracting 4. We get absolute value of 3x is less than 9. Now, this is less than, meaning it's going to be and. And what do we want to be true? We want it to be inside. We want it to be skinny. So 3x will have to be smaller than the positive number, and 3x will have to be greater than the negative number, right? This pushes it to the inside, puts us on the right-hand side of the negative and the left-hand side of the positive. Now we're going to divide these, so we get x is greater than negative 3, and x is less than 3. So we have our little sandwich here with negative 3 and 3. And we said this is everything inside. It's everything close to 0. All right, that's how we do the basics of graphing. Now we have a couple for you to try. Go ahead and do this first one. This is positive, think about, or this is greater than, think about what that means. For this first one, we're going to subtract 1 from both sides. We're left with 2 absolute value of x minus 3 is greater than 10. We're going to divide by 2. So this gives us x minus 3 is greater than 5. This is greater than, meaning that it's going to be or. Right? We want things to be on the outside, the exterior of this. So when it's or, we want it to be bigger than the big number and smaller than the small number. Right? So we want it to be on the left-hand side of the negative and the right-hand side of the positive. Now we're going to solve. We're adding 3. We get x is less than negative 2, or x is greater than 8. When we put this on our number line, we have negative 2, we have 8, and 0. Is 0 going to work for this? Well, 0 is not less than negative 2 or greater than 8, meaning that it's going to be everything on the outsides. You have one more? Go ahead and do this problem. For this one, we have a less than, meaning this is inside, or an and. And what's going to be on the and? Well, we want it to be smaller than the big number, and we want it to be larger than the small number. So we want it to be to the right side of the negative, but to the left side of the positive. Now we're going to solve for these, so we're going to subtract 2. It gives us 3x is less than negative 19, or x is greater than, negative 19 over 3. And then for this one, we're going to subtract 2, so we get 3x is less than 15, or x is less than 5. When we put this on our number line, somewhere down here is negative 19 over 3. We said this is and, it's interior, right? 0 is greater than negative 19 over 3 and less than 5. So it's everything on the inside. And that's how we graph absolute value inequalities. Now that's all we have for this lesson, so go ahead and get working on that homework.